There it is. Hi, chat. Is the audio working? I know Windows did an update, which generally ruins everything. No, we're good. What's up, chat? Happy Thursday. Welcome to another Real Good Thursday. Rin, thank you for the 16-month resub. Do we... I said welcome back to the bobbleheads. Do we have a thing? You're real. Real ones? I mean, they could be the real ones, but that's sort of ascribing a rating to them. I'm not trying to tell you what your rating is. But you're probably a 1. If you don't know what Real Good Thursdays are, chat, this is the stream that we do every Thursday where I and almost inevitably someone else hang out and talk to you about what is going on with Real Good AI, or talk to a special guest about their career, their life, and AI. This week it's both. This week we do have a guest, but you've seen him before if you've been to previous streams, and he did work for us, but now Cody is free for like a month at least till you have to go back to school. And yeah, our summer student Cody is going to be here. We're going to talk to him about his work that he did for Real Good over the summer and whatever else. If you have questions that come up about his work, we will be watching chat. If you have questions about what Real Good AI does, we can talk about that. But this is kind of a farewell stream, as everyone was conspiracy theorizing. Cody is done with the summer gig and we'll be heading back to school in the fall. So we're just sort of hanging out. One last blast. And also, Mandy and Eric are here. Doctors, Mandy and Eric are here. So we have a full house, and I'm going to be playing Minecraft. But not where you think it is. Will be. Anyway, hello. Real good team, Mandy, Eric, and hello, Cody. Welcome to possibly your last stream, maybe not, we'll see. I mean, we'll be way in the future, but we'll see. Maybe our paths will all cross again. That'd be fun.
That would.
So why are you not where you were gonna be, Bob?
So this, I mean, it's not exactly a public server right now, but this is a server that we're getting going here, and is so far I have contributed almost nothing. Everything that is here that we will have a look at is built by the volunteers. This is going to be the server where the long-term goal here is to have this be the server where we do like the guest interviews, but also where we have any future events where we want to play Minecraft. There's going to be portals to different areas. So far this is just spawn, so this is just like a shared communal starting area with like farm, tree farm, cottage, barn full of animals. My goal for today is to build an iron farm, which I've never done before, and I'm sure will totally work first try. It'll be great. But yeah, so this is a new Minecraft server. It is not public currently. It may become public at some point, but the volunteers get on, and there will be. Looks like there's Caden, Jupiter, and Utobon. I don't actually know how to say your username. Sorry, but we have a few volunteers on, and so you'll see them around, probably standing in a circle, laughing at me, wondering why my iron golems aren't spawning correctly.
Well, and if this server were to go public, it would probably be around FSA, right?
Yeah, if we do events in the future, it will be something where it's like an event where we want everyone to get on because of a fundraiser or because Real Good is doing something. No specific plans for that quite yet, but if you follow our social media and maybe, you know, our YouTube or our TikTok, you'll find out. I'm sure you'll find out. It'll be in those things. Okay, and before, I guess, since it's on there and someone asked, Kim Tana asked, why is the stream rated a 1 and why was my stream yesterday rated a 1? Honestly, it's kind of just for safety. I keep putting it back to 0 because, generally speaking, what I do is a 0 most of the time. But when I have other friends on stream, or if I'm playing video games that are new to me, which I mostly stream new video games because I'm just playing new stuff with friends, I don't know for sure that those are all 0s, because it does not take much to make something a 1 rating, right? And so right now on screen, Cody is using the background blur tool just to hide his messy bedroom. And
he said it was clean. Be nice.
Yeah, he said it was clean, but then he kept it hidden. So
Well, part of my plan. They'll
but
never know.
but that tool is just an automation from Discord or from your webcam software or however you did it. That is a 1 because it is, as far as I know, probably an AI feature where it's in real time cutting Cody out and then blurring the background. It's not complicated and it's not generative AI, but that makes the stream a 1. And so there's a lot of stuff like that where, you know, if someone uses a voice filter on a stream with friends to make a joke, that might be a 1. There's a decent chance. If the video game used some sort of automation or some sort of tool in Photoshop or some Adobe thing, could be a 1. So I'm just gonna leave it at a 1 for safety. Even though today it is for sure a 1. Most days it probably is, even if I don't think it is, because there's lots of stuff. But anyway.
Okay, thank you, Bob. Yeah, so now, Cody, welcome. So good to see you. Do you want to tell us a little bit about yourself? I just give chat a little bit about your background, where you go to school,
Mm-hmm.
your favorite color.
My favorite color is purple. I am a student of like data analytics at Ball State University. I've really enjoyed it there. I've enjoyed my classwork. A lot of math. I like to, I don't know, bake. I like to make little algorithms, program things to do stuff in my free time as well. I don't know. I don't know what else there is to say, but that's probably because I live my own life, so I know it all, you know?
Yeah, that's a good answer. Good answer. I mean, so Cody was a volunteer for Real Good AI first, too. And to be honest, we were looking for a graduate student to do some graduate research with us. And when we interviewed Cody, we were like so shocked and surprised in a good way about how good his creative thinking was in terms of research, even though he's just an undergrad. And so we were very excited to bring him on board. And do you want to tell him a little bit about like the concept of the project you worked on this summer?
Yeah. So while I was volunteering, I was doing some kind of like very calculus focused type of interpretation of data set attribution, trying to figure out what data in a data set helped the neural network actually produce the answer that it gives you. And when I was taken on here in with Real Good, they saw that and wanted to kind of build on that towards something that's more makes a little bit more sense. And so we pivoted to using Gaussian process models, which I don't know how deep into the weeds I should get with that, but that was very interesting to learn about, and I do think helped us get to a good place where we have a direction to move in with this type of data attribution and trying to get I guess to paint a picture of what this might be useful for is getting artists paid for having their data used in a data set. Because right now, like image generators, they just use everything. You don't know what they're using. They're just generating something, and it's kind of a nebulous. It made this, but it how did it know to make it that way? And that comes from data. It has to come from data. And so the thing that we wanted to do was figure out how we can figure out what data helped the model make its output. And that can help us, you know, get artists paid, get sources cited for like large language models when typically they might not be able to do that always. And so that's very exciting. That's the type of thing I really enjoy figuring out.
Great. And so this project, I think it brought up a really interesting question that had like a debate between Bob and I. There's like two ways to think about this problem, and they're very slightly different, but your solutions can sort of cover both, I think, the way that we've thought about it. So either the artist just knows that the data what has been scraped and is already in the data set. So you assume that the data is in that data set. You want to know how much it was used. Was it used a lot? Was it not used at all to make that generated image? Because it's possible it's in the data set, but it didn't help that image particularly at all. Like it's very,
Mhm.
very different. But then the way Bob was framing the problem, which I thought was really interesting, was maybe we have no access to what was in the data set, period. We don't know what data they trained on, but we want to show you had to have trained on this data. Like, there's no way you generated the same sort of image. How do we prove that it is in the training data set? I mean, obviously, it has to be influential to that prediction, because if it's not influential to that prediction, we would never know. But those are just two, like, it's just interesting to me that as you developed this problem further, we thought about things a lot more philosophically like this.
Mhm.
What
Yeah,
what framing of the problem were you thinking about? The first one?
I was thinking about kind of having access to this data. Um,
Hmm.
uh, just because I'm not very experienced in like I guess reconstructing or recovering training data. I think that there is some interesting research on that, but I haven't read too much into that. Uh, but I do think that there's an avenue to go down with the research that we've done for that type of approach, for reconstructing or at least showing that there's a suspiciously high likelihood that this particular training sample might have been included in a data set. Um,
Hmm.
uh, Clearly, there's more work to be done, you know. Uh, but I digress.
Absolutely. I mean, this brings up a good point. We should mention to chat. It's just that, like, if there is a trained model, if people can query that model as many times as they want, they can regenerate that model. It's called a distillation model. That's the
Mhm.
right words, right?
Yeah.
So basically, the point is the security of these models is crazy. I mean, how do you keep someone? I don't know. So it's a big,
Yeah, I mean
big open AI issue, and not open
that's something
AI
that's
open.
yeah. That's something that's going on in the in current events right now is that there's a big model that was developed by China called Kimi K3. That's an open source model that is getting accusations from maybe not Anthropic themselves, but definitely people high up in AI that they are actually a distillation of Claude Fable. They kind of just can't believe that it's performing as well as Claude Fable on coding tasks, and so they're saying, since there's no way they could have done it, they must have stolen from us. And so they're calling it a distillation model, where basically they just took the outputs um, from Claude Fable and trained on those outputs to sort of replicate what Claude Fable does instead of um, understanding from first principles, instead of building the model from ground up and getting the knowledge uh, through the same types of data sets.
Okay, but can I just say I don't understand philosophically why that's bad, because they're just scraping the internet still,
Hmm.
but just in
Yeah,
a
I mean,
smarter way.
it might be against terms of service or something like that. That's
Yeah, sure.
basically the only ethical, like it's mostly sour grapes, right? Like if you gave them access to the model and they paid for the model, unless it's against terms of service, they were totally allowed to be doing that, right? Like um
I know.
yeah, someone
Oh,
up from chat brings it up
AI
like,
people
oh,
don't
so
want-
the AI people don't want other people's work to train their AI models. How weird. Yeah.
Yeah.
Big bummer on that one.
I think that's very strange because I don't know. There's a lot of interesting research to be done with distillation in general. It I don't know. It seems weird to me.
And just saying that this is, even if it is actually a distillation, it's far from the only distillation that exists. I remember back in like 2025 when I was first like running open models for the first time. Some of the first models I ran were distillations of DeepSeek, because DeepSeek is like a giant mixture of expert model, and it was too big to fit on the GPUs I was playing with. So I got a distillation which I believe either used the Llama architecture or Gemma 3. I can't remember which one exactly it was. It's available on OLlama if you look at the DeepSeek distillations, but it was just a smaller version of that was trying to um, replicate the behavior of the full DeepSeek, but with a smaller model. And so these things have been around before this, like maybe at least a year, and this is the first time anyone's complaining about one. So too bad, so sad.
So Maylene in the chat is asking, I know the inspiration for this image generation was image generation, and being able to credit the artists. Would this research be useful for text or code generation? Is it not needed, interesting, since you can ask ChatGPT for sources, or
So this would be useful, and is applicable to large language models as well. I think there's just a little bit of work that needs to be done to adapt, because my implementation doesn't have attention, and that's like how large language models work is by using attention, a lot of attention. But barring that's not impossible, like barring that being impossible, if we're saying that it is possible to do that, which I think it is, I don't know why I wouldn't, then one, yes, we can apply it to large language models, and two, there would be a reason to. One big one is actually in reducing the size of the data set, because these large language models have gigantic data sets, where they pull from everywhere, and no one really knows what's all in them. They have too much data for even a large team of people to ever really go through. But reducing the size of the data set, more primarily giving citations to the text it generates. Because if you've been on like Gemini or ChatGPT, it gives you citations. However, these citations are from a process called retrieval augmented generation, where the LLM basically does a Google search and it pulls data at test time, is what it's called. Like when you ask the question, it pulls the data to give you the answer. What the technique that we've implemented is at training and test time. So it records what data it's pulling from at training time, and it can tell you that at test time. So it can tell you, like, oh, it asked this question to Google. It made this Google search. Well, how did it know that it needed to make that Google search to get the information that you wanted? Well, it used some training data from like Reddit or something, or maybe Wikipedia, and you can weigh how important or how useful this pattern is, I guess, if that makes sense. You can say it knew to ask this question to Google because it remembers this question on Reddit and it was looking for it, maybe, or maybe it wasn't. I digress. I hope that makes sense. please go more in depth with your research and what you discovered through your research. Yes.
Well, let's start piece by piece. So
Okay.
there's a philosophical difference between what we've been talking about as data attribution and what the machine learning literature considers like influence of points on predictions. Can you talk first about what the machine learning literature has done on this yet? Basically, what an influence function is.
Yeah. So the state of the art influence functions, they basically they make a map of the model in how sensitive it is to change. And whenever you try and find like influential training samples, you really just are taking that map of how sensitive it is to change, and you're trying to find training examples that have the same types of sensitivities to change. Um, the interesting behavior that this has is that it pulls out a lot of data that is not well represented by the model. It's kind of like it's the data that the model is least good at representing and is most unstable around that point. It's all wiggly, it's uncertain. And that's useful in a lot of machine learning instances because you can say, okay, all these data points are confusing data points. They're really important data points to include, assuming that they are correctly labeled, all that. But they help you make a good model, but they don't tell you what the model is actually using as justification for its decision. So our type of approach looks more for the data around the point that you're looking at. It's trying to look at the local neighborhood of data points and pick out data points that are kind of salient examples of what you requested of it, instead of just reaching all the way across the data set and saying, this is a decision boundary that's way off in the distance. And we want to use that. I think I probably got a little off track, but
You're fine. So, I mean, the first difference, maybe just to simplify it a step further, is that when we've been talking about this, we've been like, here's a generated image. How did you come to it? Like it's this percent this percent that, this percent that here. But what people are talking about here is like in a classification task where I'm trying to say, is it a camel or is it a cow? They just want to know the points that they're considering influential to being a cow or a camel are the ones that divide between the cow camel line in some way, shape, or form, right? So because they're doing this classification task, they don't need to know about the ones that are close, actually, because the ones that are close are probably all the same class, unless they're not, and then those are the influential ones anyway. But they want the far away ones that define it as that class, that like have the exterior of this shape that is keeping them in, which is just an interesting thought. I certainly didn't expect that. Did you expect to see that going in, Cody?
kind of. It's not really, but when I was doing my my volunteer work, I basically made a influence function, a very crude influence function. You know, I had just finished my third semester of calculus, and influence functions are basically just calculus applied to this problem. So it seemed very natural. But when I was playing with it during my like volunteer work, I did notice that I was unhappy with the data that it was pulling out, because while it was pulling out influential data, like I could numerically quantify how influential it was, it didn't make sense. It was pulling out data that that just it was the right class, but it looked vastly different, or it barely looked like the correct class. It was even confused. Some of them were even confusing for me. And I was like, this isn't. I gave you an example of a perfect 7, And you're telling me that what justified your decision is this 7 that looks completely different? It almost looks like a 2? That's not right. That's not behaving intuitively. And so a lot of the research that we did was, kind of more philosophical, I guess. Not more philosophical. I mean, I wrote a lot of code and did a lot of experimentation, but a lot of the learning was in the philosophy of it. I did not. I would say I did not expect that going in, but I feel like maybe I should have.
Super interesting. Yeah, it's been great to have you work on this problem because I think it definitely has changed the way I think about it, right? So, what was the metric you were using to determine the success of these different methods?
I think before we move into that, let's talk about what we did that was philosophically different. What specifically what we did that's different from how this influence function is working, right?
Sure.
So we did a Gaussian process surrogate model. That's what you guys are expecting me to talk about?
That's effectively what I'm asking, but not in so many words.
Methods, actually. I mean, even the ones you've called in the past naive are things that you generated from your mind that are not the way that people have solved this problem yet, which I want to give you major props on. Sometimes finding the right thing to compare it to is really hard, and even if, other things are new ways of doing it, usually you'll write the paper because one of those things worked out and you're like, yeah, this is my method now. But yeah, tell a little bit about the philosophy behind some of those that we were going for. You don't have to go into the gritty details.
The Gaussian process models are kind of the main thing that we focused a lot on, because they are more principled in the way that they give attribution. If you train a Gaussian process model, it literally tells you exactly how much it used of each data point. And so what we did was we basically decomposed the neural network into components that we then fit Gaussian process models to. And through that fitting process, we're able to collect that type of attribution when we run it forwards. That was probably more nitty gritty. I'm just such a nerd. But that's kind of the gist. It gives a principled approach to attribution, and that was kind of a lot of the experimentation and trial and error, making sure things work because it had the most moving parts. But we also tried running some what I called naive approaches in a lot of my work is just finding nearest neighbors, basically, where you take I don't know how to explain it really, but if you think of the neural network as like a brain and all the little neurons can light up, you try and find whichever copy of the brain has the most lit up in the same way. So the nearest neighbor, the most similar way that the neural network is thinking about the inputs that it's given. And those are...
The way I've described it is you were trying to match the path through the neural network, the path that the data takes through the neural network.
Yes. I think that's a great way of explaining. And that performed very well. I would like it to be a little more principled, because it was a naive approach. It was just something that came right off the top of my head. But it did seem to work very well. In a lot of situations, it performed better than influence functions. Now, influence functions can outperform it under some specific conditions, but I digress. That type of research was really interesting to see how, I don't know, just different these implementations are, but they can still be very similar in the way that they behave and the types of data they pull out.
Well, and to sort of roll back a little bit to talk about the difference between, and to sort of hit on the philosophy difference that we're butting up against between neural networks and Gaussian processes, the thing we're making a surrogate of. The way that I explained it during Full Steam Ahead last year is that when you make a prediction, you'd think that what is going on is that the model will reference examples that it's seen before, and then based on those examples, make its prediction based on how similar it is to what it's seen before, right? That's how one would think a model that's based off of data would work, right? That process is explicitly what's going on in a Gaussian process. That's not what's going on in a neural network. What's going on in a neural network is that the neural network is seeing a bunch of previous data, learning sort of a vibe of that previous data. It's fitting its expectations to that previous data, and then fixing that expectation and using that to make predictions. It's not ever actually referencing the data itself when it's making a prediction. And so this was something that was actually really, really difficult in this project, was if the neural network is not ever actually explicitly using data to do its prediction, how do we define something as being used by the neural network? How do we define something as how do we define an example as being important to a prediction or influential or attributable to a prediction, when what the neural network is doing is just kind of using a vibe it got from it and not explicitly using the data in the calculation? And so that's kind of why why it made sense for us to use a Gaussian process in the specific example, because it turned the usage of the data from implicit in the neural network context to being really explicit in the Gaussian process. So the whole philosophy behind the project is to make a Gaussian process version of what the neural network is doing. And because that version is explicitly using the data, we can then say what data is getting used and what data is not getting used.
Mm-hmm.
Well, and just to reiterate, because there's some discussion on this in chat, the end goal is not to generate art from what Cody's research is doing. The point is to look at these models, to replace them with understandable models, to undo the harm that has been done with them, or at least give compensation where necessary, and or get them to stop doing this. So yeah.
It's a transparency thing, because I've seen a lot of organizations kind of hide behind the black box nature of AI, and they'll be like, "Oh, well, the computer said this. That justifies my conclusion as being the same as what the computer said." But you don't know how the computer made its decision. One of the things that comes to my mind a lot is the like screening AIs that do like job screening. They're black box models. We don't know what information they are considering useful. And it's entirely possible that even if you've scraped all the data that could be, bad for it to leverage, that it's estimating that in order to make its prediction, because it thinks it's useful for some reason. It can be just as biased as a person can be. The only difference is that it won't tell you. And this type of like Gaussian process, replacing them with Gaussian process models, allows us to make it more interpretable, so we can actually see and kind of unveil the curtain. Is it really justifiable?
The black box, if you will.
Yes, illuminate the black box. Exactly. So it's yeah, that's the hope, I suppose, is that we understand these models better and we can use that understanding to make good things happen.
Maybe an example of this would be like if you're talking to a chatbot and it tells you a factual thing, and it's like, yeah, I got this from Reddit. Um, and you're like, okay, well, maybe some of the best information comes from Reddit, but maybe it's from a creative writing Reddit, right? Maybe it's like not a factual thing. Maybe it's from a something that's obviously supposed to be imaginative. Or if this comes from the textbook that this is from, like maybe you trust it more. And like you said before, there's no way that it's doing this properly right now, where it's attributing sources, it's going back and making that up itself. So yeah, that's just another example of where this might be useful. Oh, I think you should also talk, Cody, a little bit about there's another example that I think you've talked about where this could be useful in terms of saving computation. Do you want to talk about that?
Yes, in terms of efficiency, the that is a really interesting discussion, I think, because there's a lot more to just reducing the amount of data in a data set than like a lot more benefits than just efficiency. But uh, essentially, if our method, or well, yeah, using a attribution method, if you can tell what data points are highly influential to, like, all of your testing suite, all the data that you want it to be good at working on, you can see also what data is not useful, and you can get rid of it. That reduces the amount of data that has to be collected and used, which makes it once again feasible uh, for these AI companies to go through the data, and it makes it more feasible to give attribution. It makes it more feasible to give compensation. It makes it quicker to train the models. It makes it use less electricity when training the models and experimenting with them, constructing them, etc. Uh, this is very useful for that, and I don't know of why anyone would not want to do that as from a machine learning like perspective. If we can use my least favorite part of machine learning stuff is collecting data. If I can collect less data, I'll be happy. But I hope that's yeah.
Okay, so then do you want to talk? Are we ready now for the question I asked before about how do we measure?
Yeah, let's go back to talking about how do we measure whether we're doing a good job or not.
Right.
So a lot of the experiments that we ran were their leave one out type is what it's called, or well, leave multiple out, really, leave k um types of experiments. So what we did was we have a model and we generate attributions for it, and whenever we get this attribution list, and we can just delete parts of the data based on that attribute. So the highest, most influential data points, we delete all those, and then we retrain the model using that new smaller data set, and we see the impact on performance based on the attribution. So that was the kind of gist of one of the main like tests we did, and then the other is deleting from the other side. Instead of deleting the most influential stuff and seeing how much it impacts performance, we delete the least influential and see how little it impacts performance. And that was very effective. Our method did a very good job at retaining the behavior that that the base model had with significantly less data, which is great.
So as you went around and you like iterated on your results, I think the result to me that was most interesting, not necessarily for like this problem, but in understanding the differences between neural networks and Gaussian processes, was when you were kicking points out that were influential to the model, what the neural network was doing was jumping from, oh, I think it's a 5 to, oh, I think it's a 7 now. Like it was jumping what classes it very much was thinking. While as it was getting less certain, the GP was going, well, I don't know. It could be any of these classes, and just the uncertainties were sort of blowing up, and it wasn't really changing what class it thought it was going to be because it was still pretty sure, but it wasn't, as certain. Do you want to comment on that a little bit more?
Yeah, that I think is a really good highlight of the, I guess, philosophical difference between influence functions and this GP, or like, yeah, the GP based approaches and the distance based approaches, is that the influence functions, they're looking specifically for data points that most violently change the decision that the model is making. So if it thinks it's a 5, it's going to try and remove as many or as few data points as possible to make it think that it's literally anything else with high certainty. So it's not necessarily trying to make the model less certain that it's 5. It's just trying to make the model think it's confidently think that it isn't a 5.
Right.
Whereas the GP-based approaches are more diffuse. They erode the confidence of the model. They don't destroy its ability to make decisions. And it obviously, in some situations, you want it to be like an influence function. In some situations, you don't, as from a machine learning perspective. But I think that for attribution, it makes a lot more sense to have something that, when removed, makes it less certain, not something that makes it confident in a different direction.
Well, it just makes no sense that that's what neural networks do. If you can remove one point that isn't close to the data, how could that possibly change the response? Like that just shows you what nonsense neural networks are, right?
I would term this as neural networks lacking robustness.
Yeah.
Yeah, I agree. They just kind of, you can tear down these single data points that are basically like, their loss is so high during training that they're like carrying the whole decision boundary on their back, pulling it all the way over here, and then you remove that, and that decision boundary goes from way over here to way over here, and then all the little data points in between are now completely, like, the model thinks it's a completely different thing now.
Just to maybe bring this back down to a metaphor state, imagine clouds, right? There's a bunch of clouds in the sky, and in the middle of one of those clouds is the thing that you've produced, like you're interested in understanding. And that's like saying the cloud way over there is the cloud that like you is giving you that changing. Like, why is it not the cloud that is encompassing it? Obviously, theoretically, like from all logic, it should be the actual encompassing cloud, right? Like, we don't care what the cloud over there is doing. It could be raining. Well, this one is totally sunny, right? That it matters what's happening in a local sense. And I know neural networks have gained a lot of strength by being so flexible, but they do this thing called overfitting, where they find patterns that aren't really there. So like they're looking at the white noise and they're seeing pictures, right? That's essentially what's going on. I don't know if that was as much more clear as I hoped it would be.
I understood it.
I liked the cloud metaphor better before I started it.
I think maybe we're getting our jargon screwed up. Someone in chat asked the question to distinguish between certainty and confidence. I think maybe the way we've been trying to refer to these things is, well, I might have it backwards, because there's two different things that get output, right? That there's a distribution of probabilities that's the raw output of the neural network, right? It outputs
Not
logits for
probabilities.
every. It's not probabilities, they call it probabilities. So I'm saying
But it's not.
probabilities in a neural network sense. In a statistical sense, it is not. But if you don't call it a probability, they're not going to know what the hell you're talking about. So, it's the softmax of the logits that's output from the neural network, which they refer to as a probability distribution because it's normalized. So that's what's the raw output of the neural network. And so one could refer to either the confidence or the certainty. I'm trying to decide which I want to be confidence and which I want to be certainty. But the entropy of that probability distribution being low. So if it has like a 1 at one position and 0 everywhere else, then it's highly confident in that label. Right. But if you're using a Gaussian process, you get a hidden second measure of certainty. And actually, yeah, so I think I'll call the Gaussian process thing certainty and the probability distribution output of the neural network confidence. So the confidence is the how spread what it thinks the label is going to be. And then the certainty is the how confident it is in that confidence, right? It's based on the data it saw, it made that confidence distribution, and it has a level of how confident it is in that confidence. I don't know how to put it another way. It's whether it gave you that guess of this is definitely this label, this is definitely a 5 and nothing else, but it could be totally aware that it's pulling that out of its butt and so have low certainty in that high confidence. Right? That's sort of the distinction that I think we can draw.
I think that's too many layers too deep.
It is pretty deep and pretty difficult to explain, but hopefully that clarifies that there is more than one meaning to that word at play in this project.
Confidence is kind of a measurable thing for AI. I wouldn't.
Yeah, it's kind of what drives the loss in AI. It's what drives how it decides to learn from the data.
I mean, but it bothers me that we're using the word confidence, to be clear, in the same way that probabilities is an issue, because we're using it more colloquially, right? Not as in a confidence interval.
Correct.
Yes. Just to be clear, for all those statisticians out there also grimacing, yes, this is a casual neural network description of those words, not the repeated sampling bit that we're used to as statisticians. Yay.
Yeah, it's not a confidence interval.
Right.
Like you would get in stats.
Yeah, it is really complicated because between even statistics and machine learning, there's a lot of words that are different. I guess that's a good question. Hey, Cody, did you learn any definitions of words that maybe you knew before but didn't know in the way that we've talked about them? Were there any word definitions you were surprised by?
I feel like there were. I just forgot. They've been integrated into the neural net, and I'm sure there was. I remember reading several papers where it didn't make any sense, and then suddenly it clicked, and I didn't know why. So that probably means there was something vocabulary that.
Well, I guess that's a good question. How much of your time did you spend reading papers to understand the literature on this summer?
I don't know. It's hard to gauge. I know the first like I want to say week, maybe week and a half was almost entirely like reading papers, trying to understand what the state of the research is, and all the different approaches, what people think are good, what people think are bad, um, for it. But I read
Why
on and
is
off throughout
I'm
it.
sorry, can we pause for a second? Bob, what the hell are you
Bob's
doing?
pushing people in a hole.
Look, this is how this is supposed to work. I need 3
It is how
villagers
this is
down
supposed to
here.
Trapping
These villagers are going to be
in a
trapped here.
basement.
Listen. These villagers are trapped here. I'm going to push a zombie down these stairs into this boat, and this little room is going to cause a, sorry, Jupiter, I'm getting having kids. This little situation is going to cause iron golems to spawn next door in this pit I'm going to make, and the pit is going to be set up in a way so that it suffocates iron golems that spawn inside of it, thus giving me iron. Isn't it obvious?
Apparently, those
No.
are leveled villagers, whatever that means.
Look, they're not dying, and they're right here next to the village. They'll be fine.
Okay, so Bob
Apparently,
is
you're
doing
doing a
heinous
bad
crimes.
by
It was
stealing
approximately
those specific
what I thought.
villagers. They're
Okay,
saying
I
they're
apologize,
diamond level
Cody.
villagers,
No,
whatever
it's
the
great.
hell that means.
Listen, do they need to be free to do what they need to do? Because if not, they can live in my iron mine and do whatever it is you want them to do, because I don't know anything about what they do. I don't know what leveled villagers are. Listen, I knew this was going to be a catastrophe. That's what the plan was. It's okay,
Everyone's saying it's
artificial.
okay. They're artificial. That's the same way that people start treating AIs bad, and then that's when we die, right? In science fiction.
Yeah.
Yeah, how you guys feeling about your abandoned Nintendogs? Is it okay that
Oh,
they're just
God.
artificial?
Arnar.
Come back,
How
they're
are those
emaciated.
Neopets doing? Been 15 years since you fed them, huh?
Oh no.
20, probably.
What am I doing with my life? What am I doing with my... There we go.
Okay, sorry, Cody, you were telling us about the very important work that you have done.
Can't remember what we were talking about specifically.
You were just talking about the reading that you had done and how it took you a
Oh.
long time to understand that, and you spent a lot of time reading and trying to figure out what was going on with the state of the art for this.
Yes, there was a lot of so obviously there was like an initial period where I was just trying to get like an overview, if you will, of what people are doing, what people have done, generally. But then while I was working on it, I would have an idea, be like, okay, I want to make sure that like if there's a research paper on someone doing this, that's awesome. I love being able to read, coming up with an idea and just being able to read what would have happened if I had done an experiment on it. But kind of just exploring the area as I come up with specific ideas too. A lot of it was well, it's time consuming always trying to read and ingest all that information, because there is a lot. But it was very fun for me. I'm a nerd. I was
I mean,
geeking out
that
about
will serve you
principal-
well in grad school.
Yes.
Trust me. That's the first chapter of your dissertation. So, and that's the part I hated the most about the dissertation.
Yeah, I look forward to that. I'm excited, a little bit worried for applying to grad schools. But I mean, yeah, I think it'll go well.
So, Cassandra Kubrick in chat asks, "Did you have a favorite paper that you read?"
One of my favorite papers was something that I didn't even like I didn't feel like I used it properly or something. There was a interesting paper on feature attribution, not data attribution, for Gaussian process models, and I really liked that because I mean I can imagine if the future of with surrogate GPs, you could use this for also feature attribution for a neural network, and that would be really interesting.
We need to define what
Sorry.
feature attribution is.
I get ahead of myself. It allows you to, instead of looking at the data and trying to tell what data was most important for the prediction, it looks at the input and it says these input values were the most important for this prediction. So, if you have like a highly negative value for a feature, it says that this feature pushed it away from its output. But then the other
So
features,
in terms of an image, what are the features?
the features would be pixels and whatever prompt you have. But usually pixels. So it would be like, I mean, if you have a diffusion model looking at some random noise, it might say like, oh, the vast majority of this noise doesn't impact the prediction at all. But these several parts in this like orientation, these are what I think are really important. So you can you'd be able to visualize, if it was applied to a diffusion model, you'd be able to visualize the hallucination process that a diffusion model goes through in looking at the noise, hallucinating something, and then trying to draw what it's hallucinating. Yeah. Is that clear?
Mm-hmm. So, like, if you have a picture and there's only one thing in the middle pixels probably matter more than the outer pixels, right?
Yes, yes.
That cow on the beach problem, which, we have a coloring page about, just saying. But
So Kim Tana in chat asks, Cody, if you could do anything with what you've learned in the future without the fear of failure, what would you do? I think that's another way of asking, what are next steps for the project?
That is an excellent question.
If you want to, if you were to spin it off into something you wanted to do in grad school or something like that, would there be something that you'd want to do as well?
Let's see. I know there's a lot of like personal project stuff that this is kind of like spurred in my mind. Like the GP diffusion thing is that you're working on is really interesting. But that's not like the future of this project. I mean, without fear of failure, love to make something that I can concretely prove does exactly the like data attribution perfectly. But no, that's not realistic. The next steps are probably I know we talked about using variance instead of, right now we're using to get a little bit technical here, we're using some numbers from the GP called K-weights, and they are Kriging weights, yes. Kriging K-weights for short.
K-weights is the variable name.
Yeah. I like to shorten it. But yes, Kriging weights. They man, I'm trying to not just use the like dense statistical explanation. They try and find data that informs the conclusion but is not redundant. So there's no like duplicates that like kind of corroborate its decision. It's just trying to find some data points that are unique and help it make a decision. And for our purposes doing like attribution for something like crediting, that seems counterintuitive. So I think next steps are like using variance instead. And so when you remove a data point, how does it increase? I always do that. How does it increase the variance of the prediction? And using that instead, because that will give us a more like densified set of data that it's making attributions for, which will be better for doing that type of, I guess, yeah, the like the artist attribution and giving credit is going to be more useful to have a dense support set.
So effectively, I think what you mean by that is to use the certainty we were talking about before, not the confidence, the certainty
Yeah.
as what we're using to determine whether the change in certainty as being what we use to decide what points are important and what points are not attributable.
I think you've stated yet in like a succinct way, like what your conclusion was from your project, right? We've talked about how you measured it. We talked about some of the methods we compared to, but what'd you find?
That influence functions generally perform hit and miss. They perform our GP based attribution outperforms influence functions for a lot of the tasks that we were interested in, and I would say the primary conclusion is that philosophical difference that we talked about, where influence functions try and like violently change the output, whereas these GP-based approaches kind of erode it. I don't. Yeah, the work I've done feels to me a little bit more exploratory, because like I've done experiments and we have like confident results that the let's see, the GP and distance-based approaches outperform influence functions for retention, for data retention when deleting the data. But I do think that there's more work to be done in kind of rigorously proving that that is what we should be doing, not just that it has this better metric, because I'm still not very happy with the metric, but I couldn't think of a better one, and that's what basically everyone in the literature uses. So yeah, I digress.
I do think there are also improvements we could make on our method that draws from some of the inspiration of the influence function. And so, like, what I feel like I've learned from what you've done is that it's not just like how close the data is to how influential it is, but it's also some measure of how unique that data is itself, right?
Mm-hmm.
Because if that data like if it's in a cloud of fives and there's 1 3 right next to it, that 3 is super influential in what the prediction it might make, because you could take away those other fives, or that 3 is right next to it, it might pick that 3. So because it was unique, that makes it different. And right now with the GP approach, we're only considering like the data input, right? How close it is to the data. And I think there's something that we should be doing about the uniqueness of the Y, like how well it could be predicted or something in some way. But I think there's something to be gained from that, which the influence function does incorporate both closeness in Y and X in its response. What do you think about that?
I definitely think that there's there's space to grow with respect to how we interpret and work with the data. The one of the, I guess that paper that I was talking about with feature attribution was kind of an attempt at, like my implementation of it was kind of an attempt at doing something like that, where you, because we're able to do both data attribution and feature attribution, and attribute the inputs as well, we can say, okay, well, this input had these data attached to it, and this input is very important, let's say. So these data are also very important. And then this other input on another part of the image might be not very important. So the data that it pulls for its attribution is not very important. The implementation I did was really computationally expensive. It wasn't really feasible to run, especially not at the scale that I ended up doing for like my figures and the presentation I did. I would not have been able to make a figure like that with the feature attribution thing implemented. But there might be some areas to go with that. I don't. I just recall it not improving the performance that much, but also the performance was measured by a metric that I fundamentally don't like. I don't think it measures exactly what we want it to. I think it's a reasonable heuristic. But yeah, I wasn't able to come up with a better one, so that's what we had to use.
Well, that's tough.
Yeah.
That's its own paper.
exactly.
It really
We don't
is.
want scope creep.
So let's zoom out a little bit beyond just the specific research to more just your experience in doing the internship with Real Good. So here's something that one of my friends uses for their D&D campaigns. What was your rose and your thorn? What was the thing that you loved the most about the experience, and the thing that you wished you could go back and do differently, or was still just not something you felt like went right, or basically just what was the best part and what was the worst part about doing your internship with us?
That is a difficult question. I think the best part, I definitely, like, you guys were really supportive, and I don't know why, but I didn't anticipate that. You guys helped me out a lot and pointed me in the right direction, and there were a lot of times where I was feeling like, oh man, I feel like I'm not doing enough work. And you guys always made me feel like that wasn't true. I was doing a lot of good work, and that helped a lot with that. It was very nice getting to work with you guys. Thorn. This is gonna sound like I'm sidestepping the question, but I don't know. I think my biggest thorn was like working from home and having to deal with, like, I don't know, because I'm not at school, I don't have like a rigid schedule, so I had to like manage my sleep schedule all by myself. Like I didn't have a rigid thing.
That's
like
such a
I need to do
20-year-old
this.
response.
Well, and also eating. There was
When you're 30s, you're just like, all right, I'm done.
yeah. But I'm trying to. I feel like I've done a pretty good job, especially more recently with my sleep schedule, but also like eating. I'm not good at telling when I'm hungry, and so I would work like, I don't know, 6 hours, and then I'd be like, I haven't even had breakfast. I need to go eat something. But I never want to leave because it's so much fun, and I know that's not a good thing to be saying. I'm kind of a workaholic. I should not. I need to, get that under wraps, I think. But I think I did a good job handling it, and I got better as I went through, and I'm in a good spot now. I think, but I digress. So it was less with the fellowship itself, but with more with I don't know, adapting to the first time I'm in a situation like this, if that makes sense.
Well, but you sort of hid all of that well. You did not show up late to any meetings or miss any meetings, really, from what I recall. Like, you did what you were supposed to for us.
Mm-hmm.
Yep.
I
I think
showed
you're
up to one
just
meeting late.
experiencing the more free life of a grad student when you're doing research, as opposed to the going to class schedule. That
Mm-hmm.
you still have to get your work done, but it's up to you now to manage it, and that is a big change for people. And people
Yes.
do tend to go on one side or the other. And I think with people who chose to go to grad school in a specific thing, they end up on the "oops, I worked way too much" train a lot. And they have to learn how to unlearn that a little bit.
Mm-hmm. Mm-hmm. But yeah, that's once again not like it wasn't unenjoyable, you know. Like I still very much enjoyed working, um, and all that. And I mean, I'm not in a bad place right now. I've been good eating, my sleep schedule doing very well. Um, just something that I had to get used to, and so.
Yeah, I think I had a sort of similar circumstance when I was doing research projects in my undergrad. There was something that um, our school termed the winter term project, where instead of having school in January when you came back from Christmas, they had everybody do like an independent project that was related to their major in some ways. And some some winter terms I played with the music side of things, where I put that, like when I played in Carnegie Hall and Symphony Hall in Chicago and New York, those were winter term projects on the music side. But on the science side, I also did some scientific research projects, and some of them were more in depth than others. One of them I solved within a week, and then the rest of the winter term I basically went nocturnal. That my sleep schedule was reversed, because it's not like I had anywhere to be. It was just me hanging out in my dorm room. So I would just like stay up until like 4 a.m. and be like, I have a meeting at 9 a.m. Either I can get 4 hours of sleep, or I can just stay up until the meeting and then sleep afterward. And so, yeah, I ended up going nocturnal.
I've done stuff like that before. I did not do anything like that during this fellowship, which I'm actually really proud of myself for. But yeah, it sounds like me a lot.
Yeah, that sort of stuff happens. Thankfully, it was a good lesson to not do that when I got into grad school.
Mm-hmm. That winter project sounds really cool. It kind of reminds me of the thing that like got me into AI in 7th grade. It was we had my language arts teacher. We had this genius hour project. We were allowed to literally do anything for like I don't know, a month of time. And the only requirement was we have a presentation to do on it at the end. A lot of people did a lot of really cool things. But I kind of I used a Raspberry Pi, and I learned very basic principles behind like a perceptron, and I coded one in just Python, Raspberry Pi. And that was just so cool to me. It was so fascinating. I could give it like 4 patterns, and then I could give it a new pattern that uses the same rule that all these patterns were generated with, and it would fill in. It was like it knew it. It could generalize, and I was like, that's so cool. But
See, me and Mandy, we had a science teacher in middle school who had a very similar sort of approach that we had every last Friday of the month or something like that. We just had a class period that was just free exploration time, where she just said, "All right, we've got a cabinet full of science supplies. Go nuts." I don't know what your experience with that was, Mandy, but basically our experience was mixing chemicals in the sink and then setting it on fire with ethanol. Like that's,
The only
that's
thing I
about what we
remember
got up
from
to in middle
from
school.
my grade was boys decided they found forks and they were sticking forks in light sockets um, to get electricity experiments going.
Oh my.
These were the
That and
gifted
also,
kids too, right? Like,
yeah, we
of
were the
course.
gifted kids. And there was another project that people tried to do that totally failed. That they tried to do, you know, those lamps that fly into the air due to convection. They
Mhm.
tried to
Yeah.
get one of those going where you could like light the corners of it on fire and then it would float away because of convection. They were very, very interested in fire in my ear.
The only project I remember with that was like I literally went to several grocery stores with the same grocery list and I wrote down like what the prices were at all the places to try and figure out the optimal place to do like the statistical 1-to-1 t-test, I guess. Most of my things that I worked out to do when I was younger turned out to just be basic statistic tests that I could have answered them with. So I remember doing that.
Yeah, surprisingly, despite how my career has gone, I was not really attuned to science until like my last few years of high school.
Yeah, bleach, Eric.
Well, that was different. That was because I didn't know how to do laundry. I didn't know the difference between bleach and detergent with bleach alternative.
Mm.
So I was supposed to be doing something where I was trying to do like pH studies, and I thought my base, my alkaline, would be a bleach, which bleach is very alkaline. But I was not using bleach. I was using detergent with bleach alternative because it said the word bleach on it. I didn't know the difference.
Happens.
Turns out, and to be fair, it did give me basically the same result that bleach would have gotten, right? Like,
Well, turns out you can kill sea monkeys anyway by putting bleach in them. Isn't that what you learned?
yeah, that and soybeans as well. Those were both things I did. The detergent for the soybean project, the detergent didn't even go into the soil. Like it was just sitting on top of the soil instead of, so it like didn't even work.
Did you ever have to do
So
science fair, Cody?
I wish I had participated in a science fair. I never did.
Mm,
The
lucky.
closest I got was putting those Welch's fruit gummies in the microwave. And don't do
Mhm.
that. Don't do that. They
I
expand
did
and then they
something
catch on
similar.
fire.
Why do they catch
I
on
had
fire? Are they made of metal? I don't.
I left them in for too long.
Uh,
the sugar caramelizes violently.
mm.
It's same sort of thing. If you leave a peep in there forever, it'll start smoking and catching fire.
It's pretty much exactly like that, yeah. But I did that in middle school.
No, I
I
had
definitely
a
murdered some
couple.
peeps.
I had a couple miscalculations with the microwave because I didn't understand the whole metal doesn't go in the microwave thing. I thought I was so smart that I was like, when we make SpaghettiOs, why do we put them into a bowl first? Like,
Oh
why
God.
not just microwave the can? It went about 5 seconds and started sparking, and I was like, nope, never mind.
That's why. Yeah.
That, and also that's how I discovered that Arby's sandwiches are wrapped in foil. The fact that it's like shiny because it's metal. Didn't know it was metal until that moment.
Fairly recently, I had some syrup in one of those syrup containers with the peel back thing, and that peel back thing is foil, but I didn't know it. Put it in the microwave, click a button, immediately turn it off because there's sparks. When I peel it back, it looks all burnt.
Well, there was one that we ran into that was a New Year's plate that had foil trimming in it, and we didn't know it was there.
Right.
So when we put it in the microwave to heat up something from Christmas, the whole thing started like dancing and like boiling like it was, and it was like, oh, that's a problem. So yeah, microwaves suck.
I mean, moral of the story is you don't have to have never made mistakes in science to be good at science.
A lot of science is,
yes.
I mean, trying something and having it not work and learning from that.
Almost every PhD scientist I've talked to has a horror story of something real bad they did in lab.
Yeah.
You guys know mine about the mercury and stuff. I've told it before, Chet.
Yeah. Well, I mean, I think the saddest one that I did was, well, that's not the saddest one. The saddest one I did was that we had this whole experiment where we were supposed to be really precise with it. Like we had to crimp a little crucible and mask the lid and the base real sensitively, and then mask what's inside of it, and then crimp it, and then the whole thing, we couldn't touch it ever because our oils would get on it, and we had to be really precise with this thing. And I'm carrying it to the machine in tweezers because we're not supposed to touch it, and it slips out of the tweezers and hits the floor after like several hours of prepping the sample, and it's like, oh no,
It's terrible.
that's the saddest one. But the one that I felt the worst about was that we were doing an experiment in wet lab where we were trying to test what compounds would be potentially antibiotic because it would target a specific protein we had. So we hypothesized that a certain compound was had antibiotic properties, and so I was doing like a growth plate experiment where I'm setting different amounts, different concentrations of that compound, and seeing how well the bacteria grew with different concentrations of it. And so, for you to be able to do that, the compound itself has to be the solution, the dissolved solution of the compound has to be sterile, right? So you have to pass it through what's called a sterile filter. Which is just basically a fibrous disc that you just push through with a syringe. And so the compound itself was not very soluble in water. And so we decided to use a different solvent to dissolve it, something that would be much more compatible with the chemistry of the compound. And so we chose DMSO, which is like this pretty common alternative solvent that kind of smells like garlic. It's an organic solvent, and so we dissolved the compound in DMSO. I load up the top part of the sterile filter to sterilize the solution, and guess what else is dissolved in DMSO? Sterile filter itself is dissolved in DMSO. So what's supposed to happen in a sterile filter is that you put liquid on top of it, and then you have to syringe push it through to the other side so that you can like push it through the filter into your sample tube. It dissolved the disc completely and just went straight through and dumped all the way on the floor. So I just had like it, and the worst part of it all was that the compound itself was one of the major components of turmeric. So it was bright yellow. And so I made a giant bright yellow splotch all over the floor, all over my pants, all over my shoes that just highlighted you were a dumbass in this incident for like the rest of the year. I think that's that's the time I stopped with wet lab. Was when that happened. I was like, okay, I think I'm done with this. I think I'm gonna go do computers now.
Well, so there's another
So,
big difference. I mean, between like wet lab science and what we do is like our experiments run without us.
Mm-hmm.
Right? So most of the time you put it on a computer and it's coming back, and sometimes you have to babysit it because it's doing something and you need to check in on the progress to make sure it didn't mess it up or something. But most of the time we don't have to like babysit it every day. When you're a wet lab scientist, there were plenty of PhDs I went to school with who were doing things all hours of the night, whatever time it was. Like there was like a big tool, and maybe you get time on that tool, and it was like you get it from 3 a.m. to 9 a.m. Like that's just how the time was distributed. You go when the science goes. So being working on a computer, at least, it's a lot more flexible, I think.
Mm-hmm.
Plus, I can't ruin anything with my hands. So
yeah, there are a lot of benefits to being a dry lab scientist.
Mm-hmm.
It's both a benefit and a curse that you can take your work home and just do it whenever.
Absolutely.
that's true. You probably can't play with your worms at home or whatever your wet lab thing is.
No, it's usually bacteria or yeast. But there are worm people, there are fly people.
Mm-hmm.
They're usually studying very specific systems that need those organisms as well.
Mm-hmm.
That's correct.
I remember.
So, Cody,
um,
what's your favorite class that
yeah,
you've
yeah.
taken thus far in school?
Ooh. I've really okay. I feel like I'm just gonna like list all of the classes that like math classes that I've taken. I would say the kind of topic that I was most interested in, and I had a fantastic professor for, was linear algebra.
Mm.
Linear algebra was just so it's a different way of thinking about numbers in general, compared to like what is before that. And I don't know, it was fun, especially the way that my professor taught it, at least for me. I'm sure some people don't like this, but there was a lot of proofs and like kind of it was more theoretical than like just straight application of the techniques. Like you needed to know how to do these things so that you could tell what would happen. um uh and it was a very fun class for me. I've also really liked my probability and statistics coursework, just because they're so shockingly applicable in basically everything. I love it so much. It's so interesting. Um, Quantifying uncertainty is such an interesting idea to me, and it's so cool.
Welcome
so
to the dark
Mandy
side.
is kind of Mandy has used statistics to shape her entire worldview, to the point of her saying many times that everything is statistics. Physics, that's statistics.
Do they not fit statistical models? They do.
They don't believe they fit statistical models. They feel that they're describing laws of the universe.
Yeah, that they
That-
learn
that
through
they have
statistical fitting.
descriptive, not
infinitely
prescriptive, though.
precise constants.
I'm
That's how
just saying
they
Gauss
perceive the
was
world.
the father of statistics, and he was a physicist.
True.
And he made
True.
statistics because of physics, needed statistics.
Mm-hmm.
Anytime you're doing science, you are a flawed human being who can only measure with so much precision, and so all science is statistics.
Yep.
Well, and Lots of people said, lots of statisticians have said too, it's like common statistical wisdom that like if you just need a point estimate, if you just need a prediction or a guess at something, that then you don't need a statistician. But if you want to know the uncertainty, if you want to quantify how wrong you might be, if there's risk involved with it, you need a statistician because getting those uncertainties is the hard part. Making a guess is easy. Anybody can make a guess.
Yeah.
Meanwhile, engineers be like, pi equals 4.
No.
Hey, I am the worst about that. I round things really poorly, and you called me out on it the other night, Eric.
Did I?
Didn't you? Or maybe
I
it was
don't remember
Bob.
that.
One of you called me out on my very approximate estimations.
Doesn't
I
sound
don't
like a
remember
thing
the
I would do.
context.
Hmm.
I
I
mean,
didn't
that
know you were
definitely does
listening
sound
to
like a
us. I
thing
thought
I
you
would
were
do.
just-
I just don't remember.
I thought you were just committing war crimes. I didn't know you were listening to us.
I'm
Trying to feed
trying.
them. Like any good war criminal.
Yeah.
It's not easy.
Why are you stealing their beds? Just that they go to their beds?
Oh, hello, small child. Would you want to come work in my mines? No, no,
Why do
no,
they look
no,
like
no,
that?
no. If I steal their beds, they have to
They
come
don't really.
to my beds. Because I have beds over here where I
Yeah.
would like them to be. Come here,
Mhm.
They
small
don't
child.
really work. They just kind of sleep.
Come here,
think-
go in the hole, small child.
The number of beds, I think, also determines.
Go in the
like,
hole. There
how
you go.
big the village be.
Like, I'm
Doesn't
not
it?
trying to make the village empty forever. I just need several low-level losers to come exist in my area.
Do the villages like repopulate if you've stolen their villagers, or are they just empty?
Oh my god, he
and
fell in the
sad?
boat. It doesn't work if he's tiny. I understand my mistake now. No, you don't get to go in the boat. Get out of here.
Yeah, so they repopulate by you have to feed them, and so I saw Bob throwing bread at them. I think that's probably for that. But they can also make their own food if they have to have something to make food. If they don't have food, they
Oh,
won't
he
repopulate.
escaped.
Hey, bro. No, I let him out. This doesn't work
Oh.
with small children, apparently. It's designed to trap
Oh.
adults. Bruh, dude! Oh my god.
Oh
he
no,
gonna
is
go
he gonna
suffocate?
drown?
No, he
He's
can.
gonna
IE.
fit in the
Hey,
chest.
let me out and I'll help you. This way, dum dum.
Oh my god, you made a lore accurate toddler.
I don't think they yearn for the mine.
Now he would be screaming no at you.
Uh-huh. IE. Be smarter, Bob. There we go.
Why is there a secret chest there?
Well, actually, that's not really what I want. I want like this, don't I? This has a hop. Well, ideally, I'm going to have a hopper and attach it to that, and all of the water will push all of the iron ingots down into a hopper where that torch is, and then I will be able to get them all. Don't fall in! Go away! I can't use children. I need adults. What adults can I take, Jupiter?
I would always make a villager breeder first.
Put child in boat up here, question?
I mean, that'll certainly keep him from falling in anywhere, is if you put him in a boat.
It'll also get him zombified if you leave him outside.
I mean, you're fine. You just, yeah, maybe I do need to make a boat. Maybe it's right.
Stay out of the holes.
No fall in hole. Big dum dum.
It's
Hey, small
okay.
child. Oh, no, no, no. How are you still alive?
He's just
So
testing the
Eric,
boundaries
you
like
worked
another
with
toddler.
Cody a lot this summer, right? right? You were his official mentor. You met with him all the time.
Correct.
What do you think was the best part about working with Cody this summer?
I mean, it was that he was so receptive to advice and able to understand what I was talking about, even when I was just sort of rambling scientific ideas off the top of my head, right? Like, there were many times when I was talking with you that I'm like, is any of this making any sense at all? And you're like, oh yeah, I totally get what you're talking about. Like he's that, and also he had something to show every week, right? Like there was never a week that went by that he didn't um have a good standard of work finished that showed that he was making steady progress on the stuff that um was important to finishing the project, and um was going in a direction that was like he didn't need to be reoriented all that much either. That the facts that he was sort of always on the right track, and if anything just needed a little bit, we would show up with strange results that he needed help with interpreting and figuring out what the next direction is. It was not usually that he wasn't doing what he was supposed to, right? He was always on the right track. So overall, just great to work with. And he's doing PhD level research even as an undergraduate, and so I'm sure he'll do fine in whatever his next steps are. That was actually the question that I wanted to ask you, Cody. Is we know what your next steps are, but why don't you tell the audience what you think your next steps are going to be in terms of your career?
Yeah.
Okay, Mom.
Why don't you get up and sing for us, honey?
Yeah. Oh man, I wish I had. There's a video my mom has of me singing like turkey dinner or something when I was like 3, and I was on a stage in front of like 100 people, and I don't remember any of it. But I digress. My next
That sounds
steps.
adorable.
Yeah, it's pretty silly. My next steps. I'm gonna finish up undergrad. My this upcoming semester is kind of loaded. I was talking to Bob a little bit about that before the stream, where my I transferred. I started at a less expensive university, and I transferred halfway through, and I saved one semester at this more expensive university worth of money, but it's cost me one semester of time because I lost some credits that I needed to do, which kind of sucks. But aside from on top of that, this last semester I have is like 18 credit hours. So I'm gonna be busy. But I'm gonna finish up my undergrad. I'm going to be applying to graduate schools. I know one of the graduate schools I'm gonna apply to is UMich. I haven't looked University of Michigan. I haven't looked too much into a lot of other ones. I'm interested in the University of Arizona because I've got some friends out there. But like that's basically the extent of what I've looked into for that. I'm gonna look into that with my girlfriend because she's also looking at graduate programs. And so I want to go to graduate school. PhD program would be awesome. I'd love to do research
in computer science or statistics.
I would prefer to do. I think I'd prefer to do statistics, because like the thing I like. It's just weird. I don't know. One of the things that I still like feel like I could do better with is having like from first principles mathematical justification for the thing that I'm doing, like explicitly written. And now I don't necessarily think that everyone has to do that or anything like that, or that that's even a very reasonable way to do research. But I do think it's like if you start with first principles, you design an experiment, and then you like get a negative result or something, and you expected a positive result, you still have a very publishable thing because you can say, hey, this is what we expected from theory, and we didn't get that. And that's great. Then we love. But I digress. I'm maybe getting a bit too rambly on, but I like math. Is I guess the thing. I really like math, and I like having really good justifications for what I'm doing. And I'd like to get better at doing that, because right now I definitely feel like I don't know. I know a lot of math, and I there are justifications that I think I could write up. You know, I could write out in math all of it, but I'd like to start with that, and I feel like I don't know. I digress. I feel like that's something that I would hopefully learn during a more math heavy PhD program instead of computer science. Yeah.
I am obviously biased and think that's like a great decision, but there is a lot of like theoretical computer science that is done as well. So just to point that out, that it's not all coding, that there are like some of the people like Min, who used to work with us, did completely theoretical work in their PhD in computer science. So it is possible to do either way, but I completely support you, especially if what you found most interesting was uncertainty quantification and learning more about that. You're going to learn a lot about that in a PhD for statistics. So that's great.
Yeah, that's really cool.
And
like
also, I will say one thing that's generally lacking in the statistics discipline that you can bring to the table is the computer science headedness about it, right? That a lot of statisticians come at this data science world from one part of the elephant, and the rest of the world, the industry, is at a completely different part of the elephant, and never the twain meet. That's kind of actually what we're trying to do at this organization, is make the two meet and see where they overlap, what they can say about each other, sort of thing. And just having that experience yourself is really, really valuable.
Yeah.
Well, we can take maybe one more chat question if there's another chat question, but also I'd just like to say, Cody, thank you so much for your work this summer. It has been great working with you, and we've been happy to have you on our team, and it's gonna be lonely without you, but we hope you enjoy your school and go finish up your learning and then come back to us when you're done. So.
It's been fantastic working with you guys. I've enjoyed every bit of it.
I agree. I'm just having trouble not being an idiot. Hey, call him.
Getting mad at the Iron Golem.
Go
I saw
away.
that.
Go. Get. Shoo. Get.
I don't get why that guy keeps ruining your situation.
This is the thing I'm trying to create more of to farm, but he exists because he's supposed to kill the zombies. I need to get a zombie in the hole. The previous attempt, I got the zombie in the hole, but I forgot I left the door open. Hey, come over here. Come over here. Quickly.
Imtana asked, what would you recommend to people who want to volunteer the same way you did, Cody?
Join the volunteer group in the Discord, and one thing that ran through my mind a lot especially while I was volunteering, was this quote, maybe not from the best movie or anything. I mean, it is a good movie, I think. But from Fight Club, you're as involved as you want to be. Sometimes I mean, I do this in school. I did it a little bit with Real Good. I've done it on projects for other nonprofits where, like, sometimes I just kind of feel like things aren't happening, and it's like, well, that's because I'm not doing something. I'm part of it, you know. And so it is really up to you to get involved in it, and there's a lot you can do. Joining the volunteer group, talking with people, working on things. I mean, for me, it was a lot of research and stuff. I started volunteering. I just joined the volunteer group, and I was like, well, what code could I write? I'm good at writing code. I know a lot of math. What code can I write that might be useful? And I wrote some, and I put it in the Discord, and I got involved. And so I don't know. It's a very individual thing, but definitely getting involved is it's something only you can do.
You could also, next time you tell that story, quote Gandhi, "Be the change you wish to see in the world." But
Yes, that might be better.
Fight Club.
Fight Club. Yeah, I know. Fight Club is a pretty wild one to be pulling out there.
Okay, with that, I think we're at the end of our time, Bob.
All right. I'm gonna stop failing at this and start doing something else now. It's gonna totally work, guys. Don't worry. It's gonna be great. As soon as I get a zombie in the right hole, it's gonna be fine. But anyway,
like how you have your babysitter boat to keep the kid in.
Yeah. Hey, grow up big and strong. Stay in your boat. Chat, I'm
Are you
gonna do
feeding him?
No. Should I do that?
You're supposed to, apparently. I think otherwise he zombifies.
Here. Hey, eat it.
Just like a toddler.
What are you nodding about?
He's eating, isn't he?
He didn't eat. I have 3 breads. I still have 3 bread. I've had 3 the whole time, I think, haven't I? I don't know. It'll be fine. I'm going to do the raid now from my channel to the Real Good channel, chat. So if you want to do that, we'd really appreciate it. Also, Discord. Oh, please, Discord. Come on. There we go. Oh, yeah. The writing contest is still happening. It's ongoing. But beyond that...
No, it's not.
Well, it's judging. The judging
it's not
is...
open, but judging is going.
What are we doing here? Go in your... You know what? It's fine. The judging is going. It's going great. What? Oh, full steam ahead. That's what I was trying to say. Okay. It's happening. It's coming, Chad. Do you remember last year? Well, you keep interrupting me. God dang it. What? I was trying to just move on.
You're like a crazy person. You say like 2 words and then say something
And then you interrupt me and then I forget what I was going to say. Chat, full steam ahead is going to happen in whenever. Who cares? Actually, we care a lot, but it's...
We cares.
It's a streaming... Well, not enough to let me say it out loud. All right. It's coming. If you are a streamer or if you want to stream, there will be signups. Will be announced. You should follow our socials or follow the newsletter to get those. If you want to just participate, there will be ways to potentially like play games with people or fun things to be a part of or just to come watch. That should be pretty entertaining. It's in the future. It's pretty far in the horizon, but not as far as it feels. It's going to be coming up. When does that start? It starts at the in October, right?
Well, Yeah, we haven't officially announced it. Sometime in October through the first week in November, likely.
All right. So it'll be a fun event. There will be lots of streams. Mandy and I will do some kind of streaming and stuff as well, almost guaranteed. But you should check it out. And the best way to check it out would be to follow the newsletter, follow the socials, come to these streams. However you like to be involved, you should follow, sign up, put your email in, whatever it is, because it's easy to miss things. The internet's flooded with a lot of junk, but you want to make sure you know what we're doing, right? You want to hear what we're talking about, right? Right, Chad? I thought so. Also, next week, we're doing another guest interview stream. We're going to be talking to Dr. Ahmed Diallo, who does fusion and plasma physics, which I know what that is, and I just want to see if you know what it is too, chat.
That's what Amen does also, so she's going to know a lot about it.
Yeah, I'm sure they'll have a lot to talk about. So come next Thursday for the guest stream. Should be fun. Those discussions have been consistently great, consistently interesting. If you follow the Twitch channel, you'll get like notifications when we go live and stuff. Now I'm going to do the raid from my channel to the Real Good channel, so you have an opportunity to do what I just said and follow it. And we're going to wrap the stream up, chat. So thanks for hanging out. I'm glad that the conversation with Cody.
Al9985.
What? That's not real.
Thank you for the $15.
That's not a thing.
Real?
They just typed that in chat.
Oh, I got duped.
Sumo
That's not
F
real?
Primes donated $20. I mean, maybe on
Okay.
Squarespace, it's not a notification that we got on our end. You donated? Where did you donate? I don't see that
stream thing.
on whose
It
stream
is
thing?
real. Your stream
Okay.
thing. On the charity thing that you're doing on the Twitch fundraising. That's the one. On your stream.
Oh,
not
it
on-
says $15. Yes. Okay.
Yes.
Got it.
Thank you, Al. Sorry. I thought it looked real. I was like, oh no, I'm falling for scams.
No, I don't know why
you.
in my chat it didn't load right. That's my bad. That's my bad. Thank you for donating. It did come through. I also don't know why it didn't come through on a notification, but that's the thing that broke today. I was waiting for something to break today. That was it.
I
It
didn't
broke.
think you were
Something
AI
very-
until now that you said you're not AI, and now I think you're AI, Al.
That is something an AI would say.
Yes, isn't that what an AI would say?
It's also what a real person would say.
Oh my gosh, I just encouraged that zombie to end it all. That was not what I meant, man. I was just gonna come and hang out. Oh, hey, he's an adult. Look, he grew up. My baby.
Oh, he grew up. What a cutie.
All right, now you go in the
You're
hole,
gonna
you
be
idiot.
Trapped forever in the hole.
Yeah, go in the hole. Go in the hole. Oh wait, something's
He's
wrong
going
with the
home.
hole.
He's like, I'm out of here.
Something bad happened to the hole. I don't. How did some of you get out, but some of you didn't get out? I don't understand, man. No, not this hole. Anyway, chat, we should just end the stream. I'm just stalling now. Thank you so much. We're gonna raid into.
Shout out to anyone who's.
Go ahead.
Oh, I was gonna say shout out to anyone who's going to Gen Con this weekend in Indianapolis. I'll be there. Not representing Real Good, but just personally.
Just for funsies. And we're gonna
I'll probably
send.
be wearing a Real Good shirt though, so
Oh, so you'll be findable.
I'll
Death
be
oops.
visible. but
Oofs. Thank you for the prime sub.
getting paid for it, I think.
We're gonna raid into the Real Good Regiment. If you've ever seen them before,
John
they.
Macaroli, thank you for subscribing.
Yes, thank you.
Yes, enjoy the real regiment, chat.
We're
We will
out of
miss
here,
you.
chat. See you next week for the interview. Make sure you come for that. It'll be fun. Bye.